All right, so now let's plot the actual values and the fitted values. So I'm gonna open up the notebook again. All right, so I am moving down our var and data frame because remember we have a lag of 1, so I'm moving that down. I'm kind of shifting it down so it only starts at a later date. And this is dependent on the number of lags you have in the model. With right now, I'm just going with the with the default, which is just 1 lag, and so I'm just going with the default. So I'm moving down by 1, and I'm creating a new column. So remember, for the var data frame, the index is the timestamp, and then we're going to now have 4 columns. We're going to have one for X, which is log stock to flow, one for Y, which is log Bitcoin price, one for fitted X, which is the VECM estimate for the error correction model estimate for log stock to flow. And we're going to have fitted Y, which is the error correction model estimate for log Bitcoin price. All right, so now let's plot it. Oh, that's what this is. So I created a figure with the fig size of 12 by 7.5, and I'm plotting Y by just putting in var Y. I'm just calling that date or that panda series. So I'm giving it a panda series. So the index of this is the timestamp. I labeled it actual Y for the actual Y value. I colored it black, set it 50% transparent, and I did that for the rest of them. So fitted Y, label fitted Y, color blue, 50% transparent. The X column, labeled actual X, color white, then so on, and I'll put on the legend. So automatically we'll put it in the best place where it believes to be best. And here we can see that this overlaps pretty well, maybe a little bit too well. So maybe our model is overfit. Now, if you can see that large stock to flow, you can probably have some predictive power with that. So with this, you see actual X, it did have a little bit of a spike, have a little bit of a jump. The red didn't actually jump though, so the red seems to not have all the extremes. But the blue and black. So the fitted values for log of Bitcoin price and log in the actual log Bitcoin price, it is very close. So this could potentially be a sign of overfitting. So if we overfit, maybe if we add too many lags, maybe if we set it to 10 lags and there only needs to be a few, then maybe we've overfit the model. So maybe this would not be a good predictor for future Bitcoin price, maybe, or maybe not. So you could be exact. And then just to look at the residuals here, the x-axis is the residuals for our X. The y-axis is the residuals for our Y, log Bitcoin. Set at 50% transparent. Just to see, I did it again for the fitted values. So I typed that up. And here you can see the a scatter plot of fitted values for X with respect to fitted values for Y. And it seems kind of consistent with what we've been doing. And if you wanted to take it a step further, you could look at distribution plots and so on. But this, the error correction model does work for this, but this is not something, you shouldn't take this and then invest all your money in Bitcoin. I would not recommend that, or at least don't use this model for that. You should put it against more scrutiny. So you need to, to finish off the report, to finish off the project, and going forward, what else would you do? Because this may not be ready to use to actually trade on, or maybe we've shown that there's a relationship in the past. How would you use this going forward? Maybe now if we were taking it another step further, once we did have a good model, then you could potentially use Monte Carlo simulation. You could have, you can see that stock to flow may not be that difficult to predict. And of course, it's based on the number of block heights, and that's kind of deterministic. We already talked about the Bitcoin supply, and that's what that's based on. So if you had a good model for the supply of Bitcoin, then you could potentially um, have some predictive power for the actual price of Bitcoin, assuming that these are co-integrated, which they are, or at least historically. So historically, this works. Maybe that won't work tomorrow. Um, but and again, this data only goes back. Um, let's see how far this data does go. So we have far, we have the index. Really, let's just do tell. Let's look at the last few rows, and we have up to um, July 23rd, 2019. So possibly this relationship may have changed. So of course, if you were to use this for actual or for real applications, you'd want up to date data. Maybe you'd want to test it. How well did it perform based on the last almost 10 months? So about 10 months of days have happened since then. So if this is a good model, then if you predicted or if you estimated 10 days or 10 months into the future, I mean, you couldn't be too exact with that, but you could estimate um, or forecast 90 days in the future, compare that with actual 90 days that occurred after this. And if it is a good fit, then it shouldn't be too far off. And then if that's true, then maybe the coefficients are roughly these numbers. And if they are, then potentially you could estimate the stock to flow, log stock to flow ratio, and continue that into the future. And then maybe you could have a reasonable model for Bitcoin prices. But there's still a lot that you would want to do. This isn't ready to, based on what we've done so far and based on everything you will do in this project, it is not ready to use in real life applications. You'd still want to do a few more or analyze it a little bit more in detail before you would use this for actual applications.